All right, everybody, hello, and welcome to our fourth topic, displaying and visualizing data. So today's the first bit of math in the class. We've gotten away with no math for our first few topics, but today we're going to start with some very basic data organization about how to display and visualize data. And we're going to talk about why. We're going to talk about why these steps are important and what it can tell us about the data sets that we are working with. So let's go ahead and hop over to our slides. All right, so we're talking displaying and visualizing data. So first we're going to talk about variables and talk about data in itself, right? How do we refer to data? We just talked about types of data in our last topic. So here's some more concepts for us to consider here. We have variables, which are any characteristic that can have different values, right? So remember, this is as simple as, say, a yes or no question, up to anything that has more variant characteristics, right? Characteristics that can have different values. So take a stress scale, the age that you might report for yourself, gender, religion. Any variable will have a possible number or category that a score can have, or a value. All right, so variables have different values. So maybe we have a stress level on a scale of 0 to 4. Maybe we report age at a certain level. Maybe we have a number of categories for gender. And then we talk about scores, which are particular values for an individual. So why do we have this structure or this organization? It's because we like our data to be in nice little boxes. That's what we're trying to visualize here. We like to keep our data separated from each other so it's clear and distinct. And remember from last time, the type of data that we have will indicate what type of statistics we can run on a given data set. So here's our basic terms here. We will talk about variables, meaning anything that can vary, right? We're about to talk about dice rolls, right? We can get different varied outcomes from dice rolls, the possible values that we could obtain, and then individual scores. So there we have it. And what are we going to do with data today? We're going to start with a nice little tool called a frequency table. All right, we're going to organize data into a frequency table. All right, so first things first, what is frequency? Frequency is how much something occurs, all right? Frequency is how much of any given thing we have, right? How much does any one value occur? So we're going to make an ordered list, and we're going to organize some data and put it into a nice table, and we'll see what we can derive from a table like this. We can take somewhat chaotic data and crunch it into a table, and we're even going to visualize it with a graph later. That takes us a long way from just a mess of data that we begin with. So frequency tables are kind of a base organization for data. So we're going to make a table that looks something like this, but we're going to add a little bit to it, all right? We're going to include all possible values. We're going to tally or figure out how frequent each of our values are. And then we're going to calculate percent from there. That's our first descriptive statistic, as a percentage or a proportion. So let's take a look at this next slide here. Let me get my head out of the way. This slide is meant to be a reference slide for you if you need help with the steps for a frequency table. If you're taking, say, notes for this class, I wouldn't necessarily write this down. This is more for your reference. And we're going to do this by example in a moment here, so I would hang tight for that. But let's go ahead and read through and think about what we're going to do with the data once we have it. We're going to list every possible value from lowest to highest, okay? So we're going to have a range of scores. We'll talk about that when we get a look at the numbers. A range of scores, we're going to organize them from lowest to highest. Then we're going to go through the scores and mark each one. Make sure that every one is included in our frequency table. And then we're going to make a table to show how many times each value appeared. So again, we'll go through this process in a moment. And then the bit that we're really going to do, our first math, all right, is we're going to figure out the percentage of each score in a data set. And we do so by taking the frequency value, and then we divide by the total number of scores, or n, right, our sample size. And we multiply by 100. So simple percentage percent calculation we'll be doing for this data set here. And what data set are we working with? Let's start with, let's see, some dice rolls. Whoa. All right, some dice rolls. Okay, let's take a look. This is an example from Settlers of Catan, a board game we may be familiar with. In the game, you roll 2 6-sided dice. All right, that's all you need to know for this example. You roll 2 6-sided dice on every turn. So let's say that we're taking a sample of 25 rolls from a given game, all right, using the example of dice rolls. 2 6-sided dice are rolled, meaning that our range of values is anywhere from 2, all right, 2 1s being rolled, to 12, 2 6s being rolled, okay? And then we have a sample of 25 rolls from a given game here, all right? So if we take a look at this data, we can determine a few things, right? We can see that some numbers were rolled more than others, all right? See, we only have 1, 2, while we have more 6s, 7s. But we can't say much about this data right now, right? If we want to do some statistics and describe this sample, we need to do something a bit more, right? So the first thing we can do with a data set like this is create a frequency table. So what I have here is, on our next slide, a template that we can use to create a frequency table. So taking a look here, we have a couple of columns. We're going to have a column where we list every possible value for dice roll. We have a frequency column where we're going to list off the frequencies of each dice roll. We're going to calculate percent and then report percent. All right, so treat this as a template here. And then I'm going to go ahead and hop over to the whiteboard, and we're going to give this a go. All right. So the first thing I'm going to do is bring over our data set. So if you're working on this yourself, my advice to you would be to write down the data set. All right, that'll be your first step. You want to write down the data so that we can start to work with it. I'll have it appear up here in a moment. All right, so there we have it. There's our 25 dice rolls. Okay, and if we take a look at the table, right, the table that we're trying to create, we want to list off all possible values that we have here for dice rolls. In the question itself, it says that we have values ranging from 2 to 12. So that's the first thing we're going to want to start with. Then we want to get a frequency or a tally of how often or how frequently each of these are occurring. So let's go ahead and get a few things in here, all right? So our n, right, remember n from our first topic. N is our sample size, all right? So n is equal to 25 here, all right? We have 25 values. We're going to need that for our percentage calculation. So let's also go ahead and get our table going here. We're going to make a table. So what we want to do is we want to get our dice rolls accounted for here. So I'm going to go ahead and write right here. We're going to do dice rolls. All right. So we have a column for dice rolls. We're going to create a column for, we use lowercase f for frequency. All right. Then we're going to do a percentage calculation. We'll call that percent calc here. And then we're ultimately going to report the final percentages, all right? So this is what we want to figure from this particular data set. So let's give it a try, all right? So again, this is the very simplest first step we can do with any given data set. So let's go ahead and I'll show you how I like to handle this, all right? So we have values ranging from 2 to 12. So let's go ahead and start by getting those values here underneath dice roll. So I'm going to start with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these are all possible dice rolls. And now we want the frequency, all right? So you might already be thinking to yourself, Why are we doing this by hand when we have technology that could tell us this in an instant, right? And that's a great point, which is why we don't spend all too much time working things out like this by hand. But it's important to know what pieces go into something like a simple percentage calculation. Percentage is used all of the time in statistics reporting, so it's important to know how we get it, right? How do we derive a percent? All right, so let's go ahead and go for frequency here. So if we want to get the frequency of each of these values, we should start by crossing out which values we've already included in our data set. So let's just move through. I'm going to start crossing off those that I tally for our frequency. So I'll put a tally mark of 1 here. All right, now let's move on to threes. We have 1, 2, 3s, okay? So 2 3s, we have 1, 4. All right, we have 1, 2, 3, 5s. All right, we have 1, 2, 3, 4, 5, 6s. 1, 2, 3, 4, 5, 6s. We have 1, 2, 3, 4, 5, 7s. All right. Okay, we have 1, 2, 3, 8s. 2 9s. Okay, and oh no, we don't have any 10s, all right? We don't have any 10s, but we have it here on the list. What do? We don't panic. We just don't put anything there, all right? We just go ahead and leave it as 0, and we move along, all right? We got 1 11, and we got 2 12s, all right? 2 12s. Okay, so you can tally or just write the value in here, whatever is better for you. I like to tally because then you can kind of edit along the way, right, if you miss one. All right, so we have our tallies here. Now we want to calculate for percent. So for our percent calculations, we have a little formula that we use to calculate percent. Let me go ahead and get it over here for us. So percent is equal to a frequency, okay? So F all over our N, okay? N we have right here, times 100. Okay, F is equal, percentage is equal to F over N times 100. So what we're going to get here is a proportion, right, of how frequently each of these values occurs in this data set, divide by the total number or the sample size of the data set, and then we're going to multiply by 100. So let's go ahead and give that a go as well. All right. Okay, so starting with our 2s, okay, we have a frequency of 1 dividing by 25, okay, gives us something like 0.04 times 100. Okay, so then we can say that 4% of all of the rolls were 2s. All right, we can move along here. We can say we have 2 3s, 2 over 25 gives us 0.08 times 100. 8% of all rolls were 3s, okay? And we can go ahead and move along down to 4s. This is the same as our other calculation here. Okay, so we'll include this. All right, and then we just move on down the list. We do this for every value in the set. And I will go ahead and do that here. I know this is a little bit sloppy here, but I will go ahead and show you a slide with all of this nice and neat. But I do just want to show how we do this, right? How we do the math here. So I'll go ahead and get the rest of these in here. And so it goes. So this is a little bit, right? Maybe a little bit tedious is the word. However, it's just a procedure, right? It's just a series of steps. We can get through these pretty quick once we have our bearings with the data set. So let's keep on going here. All right, 12%, we got 2 over 25 equal to 0.8. All right, times 100. All right, then we're down to the 0 one, right? We don't skip it, right? We don't skip it because 0 is meaningful, right? It's meaningful that we don't have any 10s. We don't just skip it. We don't just ignore it, right? But we do include it. Okay, so 0% of the rolls were 10s. Okay. Down to our last one here. All right. And there we have it. All right, now we have a beautiful frequency table. All right, so we went from a little bit of a mess of numbers like we have in our original data set to being able to report what percentage each role was in our sample here. So what do we do now? All right, what do we do now? There's a few things we can do. Here are a couple steps that can help us a little bit along the way. Something you might want to do is do a sum score, all right, a sum score of our frequencies here. We're going to learn about this symbol in the future here. But an uppercase sigma means to sum. We can sum all these up and make sure that we have all 25 scores accounted for. Right? That's a good place to start. We could also sum up all of the percentages here. We want to make sure that we have 100%. And if we add this up here, I believe that we do. So let's go ahead and hop back over to the slides here. So on the slides here, I have this in a bit of a neater format for you to take a look at. But this is what we've done. We've taken all possible values, we listed them off, listed the frequency that each one occurs, and then we've calculated percentage for each. So again, we've gone from being able to make only a statement saying something like some roles were outcomes more than others, to now we can say something specific. We can say that 6s and 7s were the most frequently rolled dice. We can say that 10s were not rolled at all. We can make a number of statements about this data now. All right, so there we have it, our first math. It's not so bad, right? I tell you, I promise. We don't do any math. That's all too challenging, nothing beyond a square root. So even if we don't feel as confident in our math skills, just bear with, right? We ramp up pretty slowly with this stuff. So let's go ahead and try for another example. Let's try here, using pain ratings and fibromyalgia. Right, pain ratings and fibromyalgia. We talked a little bit about pain when we talked about types of data, right? Pain is difficult to assess, but pain is useful to assess in a number of disorders, right? Something like fibromyalgia where we have nerve pain. We're interested in measuring pain even if it is difficult. All right, so let's go ahead and give this a try as well. All right, let's go ahead and try to get these in order here. We have a sample of 30 fibromyalgia patients who are reporting their pain on a scale of 0 to 10. So let's go ahead and go through these motions again. All right, so if we hop back over to the whiteboard, let's get ourselves a fresh slide and let's get our data over here. All right. Okay. All right. So if we hop back over to the slides here, here's our data that we're about to work with. But if we take a look, we're doing the very same thing. We're going to create another table. We're going to list all possible pain ratings, tally the frequency that each one was reported, calculate the percent for each, and then report the percents and make sure that we have 100% of data accounted for, or at least very close, all right? So let's hop back over to the whiteboard, and I'm gonna put in a couple things. I'm going to put in this time, instead of dice rolls, we have pain ratings, so let's go ahead and get that in here. Okay, pain rating. Okay, we need our little f. All right, we need our percentage calculation, and then we need percent. All right, we're going to report the final percent. All right, let's scoot these over a little bit. Okay. All right, so let's go ahead and get to it here. All right, we have the data. So let's start tallying it up and including it here in our table. All right, so this time we don't have the luxury of having, say, everything organized from least to greatest, so we have to be careful, all right? So again, doing this by hand does take a little bit of work, a little bit of focus, but a lot of data entry, even with as much automation as we have, is still done by hand today, all right? It's still done by hand because oftentimes we have data in a format where it was given to us by hand, right? Handwritten in, say, a survey. So this is not entirely obsolete here, but let's go ahead and give this a try, all right? So we have ratings from 0 to 10, so let's start by putting those over here in our pain rating column. Okay, so 0 to 10 here. And let's go ahead and try tallying these up, right? Let's start with 0. So we move through and look for any zeros, and when we find one, we should cross it off, all right? So we have 1, 0. All right, now let's look for ones. We have, I think, 1, 1 here. All right, for twos, let's see, we have a 2, we sure do. There we go. All right, let's look for threes now. We have 1 here. We have 1 here. All right, we have 2 threes. We have how many 4s? We don't have any 4s. All right, so what do? Do we panic? We don't. We just move on, right, to 5s. And we have, let's see, we have 1, 2, 3 5s. All right, 1, 2, 3 5s. Moving on to 6s, we have 1, 2, 3, 4. All right, 1, 2, 3, 4. And we have 7s. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that one's pretty frequently occurring, right? We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then on to 8s, we have 1, 2, 3, 4, 4 8s, 9s, 1, 2, 3, 3 9s, and 1, 2, 3 10s. Okay, 1, 2, 3 10s. All right, okay, now that we have all of our frequencies reported in here, we can go ahead and just move straight into our percentage calculation. Remember that we had an n here. All right, our n was equal to 30. All right, n equal to 30 here. So we're going to take each of our frequencies and divide by 30. All right, then take that proportion and multiply it by 100. So we have 1 divided by 30 gives us something like 0.033 times 100. All right, gives us 3.3%. And we just go ahead and move on down the line here. Okay, so again, we go ahead and calculate each one of these out. If we get to a 0, what do? We don't skip it, right? We just go ahead and include it here in our calculation. All right, 0%. And we're going to do this on and on and on, right? All the way down the list here. I won't bore us with the rest. But this is the procedure here. And what else do we want to do? Again, we should take care to say sum this, maybe even before you begin your percentage calculation steps, right? To make sure you have all the data accounted for here. This should equal to the size of our sample, right? We should make sure that everything's tallied. If you count this up and you get something like 29, then you know that you're missing a value, and likewise here for our percentage column. So let's go ahead and hop back over to the lecture, and I'll show you our completed table here, right, with all of our frequencies, all of our percent calculations. And a few things to point out here. If you look at the frequency column, all right, I have a total row at the bottom, all right, total row. That's where we have concluded that we have all 30 of our data points included in our frequency tally. When we calculate for percent, we equal 100, or at least very close. You'll notice the total percent column adds up to 99.9%. That's not quite 100, right? That might worry us, but not to worry. If it's such a marginal difference, we will say it's just due to rounding, right? Just due to rounding, since we didn't include every decimal off of our calculations here. All right, so there we have it with basic frequency tables. All right, so let's go ahead and talk about how we might start to visualize this type of data. We have a type of graph called a histogram. And histograms are designed to display data like this. Histograms look a bit like a bar graph. Remember, we took a look at a bar graph with types of data. We use bar graphs to summarize nominal data. But histograms are bar-like graphs of frequency distributions where we plot the values on the horizontal axis and we plot frequency on the y-axis. So we take all of the values that are in our data set and plot the frequency that each one occurs. This is going to give us something called a data distribution, and we're going to spend a lot of time in this class looking at data distributions. How is the data distributed in any given data set? So here's a depiction of the differences between a histogram and a bar graph. Though they look similar, they're different, all right? A bar graph has no inherent order to it, much like our nominal data or nominal categories. And we have spaces in between the bars to illustrate that there are distinct group differences. However, a histogram, we have no spaces between the bars, and our categories or groups or bars move in a numerical order, right? They move in a numerical order. So what's the point of visualizing our data? What's the point of, say, making a histogram? Well, it can help us to describe the shape of a distribution, which can tell us a bit about what's going on with the data. So we're going to consider a few different types of distributions here. And you'll be expected to be able to describe the shape of a distribution or a plot that we make. So here we have 4 major types or shapes. Let's go ahead and start with normal, all right? Normal in the top right here. A normal distribution means that we have most scores in the center of the distribution. So we're going to get a lot deeper into the normal curve when we get to probability and hypothesis testing in this course. But we expect most data to be normal. Normal is this kind of magic phenomena in statistics and in mathematics where we generally see most scores cluster around some type of center point in the data with fewer extreme scores. Let's take a couple examples. We can think height of people, right? It's not so often we see someone incredibly short, right, or incredibly tall. Most people are around average for height. It's just kind of a law of numbers. We can take IQ scores as well. Most people are of an average IQ. We have very few individuals on either side of the spectrum. And we can expect the same to be true of where probability comes into play. Take dice rolling, for example. If you've played a game that involves rolling 2 dice, you know that rolling things like 2s and 12s are less likely to occur than values or outcomes that are in the middle of the scale, right? Just due to the probability of the dice. So a normal distribution looks like this, means that we have a peak in the middle and fewer scores on the end. So we'll start to see this shape a lot in the class. So that's normal, and these others that we're considering are a bit abnormal, right? Abnormal. So bimodal means, we're going to learn about the word mode when we get into our central tendency topic. But bimodal basically means 2 middle points or 2 peaks in the data. That's interesting because then it looks like we possibly have 2 different groups or distinct categories within our data set. And then we have a phenomena called skew, data set being skewed. We have positive skew and negative skew. I think that these are named a little bit in an interesting way, but positive skew means that we have fewer scores on the positive end. Fewer scores on the positive end. So what I like to think about with these is we call our curves, we say that they have tails, all right? Tails are the bits on the end. So what I like to say is whatever tail you can grab, all right? Think about reaching in and grabbing the tail on the distribution. That's the side of the skew. So for a positive skew, you can reach and grab the tail on the positive side. So that's a positive skew. For negative skew, you can reach and grab the tail on the negative side, right? And by positive and negative, we're just talking number line, right? On a basic number line, we have positive values to the right, lesser values to the left. So we're going to practice this and we'll think about how we might call these distributions, what we might say about them. All right. Let's take a look. Here's another slide where we just have these steps of how to make a histogram. So these are just to help guide you in case you forget, right? In case you need a refresher after our examples here. So to make a histogram, we first need a frequency table, and luckily we have 2 of those on hand for us, right? So we need to make a frequency table. We need to put your data values on the x or bottom axis, and then we make a scale for our frequencies on y or the axis on the left. And then we make bars above each of those values to represent the frequencies. So let's go ahead and give it a try. Let's go ahead and give it a try first for our dice rolls example here. All right, so if you have, what we need here is really just the dice rolls and the frequencies, right? That's all that we need. So let's go ahead then and hop back over to the whiteboard, and let's go ahead and get ourselves some fresh workspace here. All right, so if we get all of our dice rolls, I'll go ahead and put the first part of our frequency table back in over here. So we need, let's get our dice rolls here. We have, I'm just going to call them X and Y here. All right, X and Y, because we're talking our X axis and our Y axis. So for the X axis, we need to have all of our possible rolls. Okay, so let's get those in here. We have 2 through 12. All right, so we have 2 through 12. And then we have the frequencies, right, that we got from tallying these up. Okay. So then what we want to do is just make a basic graph here. So let me go ahead and get one going for us. And I do apologize, though I've practiced with my little drawing pad here. These are still definitely imperfect, so just be patient with my drawing here, please. But we're going to get in a y-axis and an x-axis. Okay, so we have our y-axis is for frequency. Okay, frequency goes on the y-axis. And for the x-axis here, we're going to have our dice rolls. All right, so we're just going to create a graph using this information. So how do we plot all of this onto the graph here? Well, first we need all possible dice rolls. Okay, so I'll go ahead and put those in here. Okay, we have all possible dice rolls, and then we need all possible frequencies, all right? So we have things that are not occurring at all, and then we have the most frequently occurring being at 5, all right? So we need to be able to indicate up to a frequency of 5. All right, and for each of these, again, please mind my drawing here, but I will do my best. So if we have, for the value of 2, right, if we only have 1, 2 present in the data set, what we would do is put a bar right here over 2 that indicates that this was rolled once. So notice a few things here. We're putting the bar centered over the number 2. This will come into play a little bit later, all right, when we have what we call grouped frequency tables, where this will indicate a group here, a single bar. But for now, we're just putting a single bar over each individual value. So then we move on to 3s. There were 2 3s present in the data set, so we would go ahead and put a bar over 3. We would go to 4. There was 1 4. Right, then we'd go to 5s. There were 3 5s. And move along this way. All right, we had 5 6s, 5 7s. And you'll start to notice a shape of this data taking place, right? This is gaining a little bit of a shape. And then that's what we're going to do next, is assess the shape of this distribution. All right, and we're to 10s again. There were no 10s, remember, so what do? Do we panic? We don't, right? We just leave it alone, right? We leave it empty. We leave it blank. There were no values there. And then we just continue where we left off with 11, and then on to 12. Okay. And there we have it. We have a histogram, right? We have a histogram. So what are the components to a good histogram? It would be, all right, having labels, okay? At the very least, we need to label these X and Y, right? And then F, and then whatever our values are, right? In this case, they're dice rolls. Then you should also be able to describe the general shape of the data, right? How is this shaped? I would call this, right, though it's not perfect, I would call this relatively normal, right? Most of the scores are clustered in the center with fewer scores on the end. So I would describe this here as normal, right? Or that this is a relatively normal distribution. All right. Isn't this fun? There's drawing in the class. Bet you didn't expect that. Very fun, all right? And you all make very beautiful histograms. Students always take time to make these so lovely. All right, let's go ahead and try another. Let's try for our fibromyalgia example as well. So let me go ahead and pop us back over to the slides here. So we're going to do the same thing here. We're going to take the pain ratings. Okay, so that'll be our X value. We'll take all of our pain ratings and then all of the frequencies here. We're just going to put them into a histogram. We're going to see how it's distributed. So let's go ahead and do that. Let's hop back to the whiteboard. All right, let's go ahead and get our values here. So again, I'll just call these X and Y for now, right? Because we're making a graph. Okay, so X and Y, we have pain ratings from 0 to 10. Go ahead and get those in here. And then our frequencies, all right, we have 1. Sorry if you can hear the dog jingling, but she's here. I know this isn't one of our live sessions, but I'm very interested to see how you all are feeling about online education. That's something we'll definitely talk about here in this course because it's certainly been interesting, hasn't it? Okay, so there we have it. We have our values, all right? So we have our X values, we have our Y values. Let's go ahead and make ourselves a set of axes, all right, our y-axis and our x-axis, and let's label them. This is our y, that's for frequency here, and then for our x-axis here, we have our pain ratings, right, pain ratings. So we have pain ratings 0 to 10, so let's go ahead and get those in here. I'm actually going to make a tick mark for 0, just so that we can really indicate that 0 was in fact selected. Okay, and then we need our frequencies, right? We have a different cap for frequency here. We have the most reported score being a frequency of 8. So we're going to go ahead and label this all the way up to 8. Okay, let's go ahead and plot this. So for zeros, we had 1 person report a 0, we had 1 person report a 1, 1 person report a 2, 2 people report 3s. So I hope you see what I'm doing here. I'm taking each of these as a set, almost like coordinates, right? For zeros, right, we go to 0 on X and we go up to 1 on Y, and we're doing that all the way down. For 4s, we didn't have any. For 5s, there were 3 reported scores. For 6s, there were 4 reported scores. All right, for 7s, there were 8 reported scores. We're at a big tall bar here. Whoa, a little wonky, but that's okay. All right, 4 8s, 3 9s, all right, and 3 10s. Okay, so again, not the most beautiful graph here, but we can at least see the shape of the data. And if we were to say describe this, we'll notice that this is a little bit different, right? We have many fewer scores here at the left end, right, or on the negative end. So we would describe this as having a negative skew, right, a negative skew here. All right. So 2 histograms under our belt, pretty good here, all right? So let's go ahead and hop back to our slides here, and let's consider one more thing, all right? Let's consider one more thing when we're talking about organizing data. Let's take a look at this data set here, all right? How would we approach this data? Right, if we go ahead with our previous instructions, what we'd be doing is listing the range of all possible values here. And in that case, all possible values are a pretty wide range, right? Starting at 310 all the way up to what's our highest value here? Something like 800, like 820. That'd be a pretty long frequency table, right? It'd be a little long if we listed every value from 310 to 820, right? That'd be over 500 scores. So that's not what we want to do, all right? That's not what we're looking to do. What we're looking to do is to organize this in a more meaningful way. And the way that we can make this a little bit more meaningful is creating groups for the frequencies. So we're going to hop back to this data in a moment, but let's go ahead and take a look here. We can do, oh, so sorry about that. I'm trying to move my little head. There we go. Group frequency tables can handle data sets with very large ranges, and they do so by using intervals or groups of scores. And we want a logical interval size, something reasonable for the data that we're looking at. Nice round numbers like 5s or 10s. If you're working with a smaller data set, something like 2s or 3s, and sometimes even larger, maybe groupings of something like 50s or 100s. But at the end of the day, we want about 5 to 15 intervals for a given data set. So we have a little bit of a procedure for determining this, but for our sake here, I'll be giving you intervals to work with. So let's go ahead and first consider for this data set intervals of 50, right? Intervals of 50. And of course, what are these scores? They're credit scores, all right? Credit scores. We maybe don't want to talk about credit scores amidst our financial crisis, but it's okay, right? We're looking at credit scores here. We're often using groupings for credit scores, right? To help explain where you fall in terms of the distribution of credit scores. It's data, just like anything else. So let's go ahead and start by grouping the data in this way. So I'll take us over to the whiteboard. We'll get us a new slide. And I'll get the data over here, and let's go ahead and give this data a go. All right. Okay, so we have here a number of scores. We're not actually going to do, in this case, percentage calculations. I'll include them here on the slides, but for now we're just going to consider working with the intervals, right? How do we work with these intervals of data? So here we have the scores, and let's take the groupings that we were just looking at. Okay, groups of 50. So let me go ahead and show you how we maybe would figure out how many of these intervals that we want. Okay, again, these will be given to you, but just to think about it a little bit. What we can do is we can get a range of the total scores. We're going to learn more about range when we talk about central tendency on our next topic. But if we start here with range, okay, how do we get a range in data set? A range is the largest value minus the smallest value. And in this case, we have the largest value at 820 and the smallest value at 310. So again, we have over 500 points here. So how do we logically get 510 points into, say, a histogram where we only have somewhere between 5 and 15 intervals? Well, we can say out of those 510 scores, maybe we want about 10 intervals, right? About 10 intervals. If we do the division here, we get something like 51. What this is telling us is that our intervals need to be at 51 if we want 10 categories. So if we want to say do nice clean intervals, remember we want clean intervals of 50, we would have something like 11 categories, which is what we're going to do. Then of course, if you wanted, say, less categories, right? Say you want a smaller histogram, if you do this division here, you get something like 102, meaning we maybe need 6 categories of about 100. So again, don't worry about this. You will not need to determine this for our class, but it's just... don't want to get rid of the data here. Let's bring that back. But that's the procedure, right? We think about how much data we have. Man, it doesn't want to let me keep the data here. Oh, so close. Okay. All right, so let's go ahead and give this a try. Let's go ahead and give this a try with intervals of, say, 50. All right, so let's do x and y again. All right, x and y. So x in this case is scores. All right, y in this case is frequency, as always here with frequency tables. So for our scores, let's say that we're going with these intervals of 50. Okay, 300 to 349. Something else that we consider when we're creating these groups here is that we don't want any overlap between our groups, right? If we had this from 300 to 350, and then this one from 350 to 400, then this 350 value that we have up here in our data would belong to two different groups, and that's no good. So we want categories that do not overlap. So I'm going to go ahead and put the rest of these in. Trying to keep it a little bit neat for you all. I'm telling you, I've gotten a fair amount of practice on this drawing pad, but it's just not the same. You know, my penmanship is not that strong to begin with, so we're doing our best, and I do apologize. That's why I try and keep at least nice typed versions of everything on the slides, so that you can at least reference that if this is a little bit hard for you to read. Okay, so we're going through and getting in all of our categories here. Notice that this is a little bit, we have a lot going on here, don't we? All right, a lot of categories here. But we have now distinct categories where we're encompassing a range of over 500 scores in about 10 different intervals. So let's go ahead and get the frequencies in here. All right, in the 300 to 349 range, looks like we have one score. All right, one score. We have an n here, kind of an awkward n. N's equal to 22 in this case. And again, I will put the percentage calculations up here for us if you want to do it to practice, but just for the sake of time, we'll leave percentage calculations out of this here, and we'll just look at how intervals can affect data distribution. So let's keep on going here. How many do we have between 350 and 399? Looks like we just have the one. 400 to 449. Let's see, we have one. All right, 450 to 499. We have, let's look, one. All right, 500 to 549. We have, let's look. Again, I know this is not the most exciting thing in the world, but I promise you, it's just our start, right? We're just starting out, getting comfy with just basic statistical concepts. Just how do we manage data? All right, so now I'm on to 550 to 599. We have one, we have two. Let's see, do we have another? There we go, one more. All right, remember just to be patient. If you move too quickly here, it's very easy to overlook a value or two. So now we're on to the 600s. We got 600 to 649. We have one, two, three. Looks like we got four of those. 1, 2, 3, 4. Looks like we have two of our next group. All right, 670. All right, we got two of these. We got in our 700 to 749. What do we got? We got one, two here. All right, one, two. I'll go ahead and do the rest of these here. Missed our 680 here. All right, let's go ahead and get the rest, our 720 there, 800 here, just for the sake of time here. Then we're down to, we got three of these, we got two of these, and two of these. All right, so remember, I like this crossing out method because then you can go ahead and say, okay, I have every single one of the scores here accounted for down here with a tally mark. And then, of course, you can go ahead and sum up your scores here to see that you got all 22 of our scores in question, right? So you can add all of this up and make sure that this is equal to 22 here. So let's go ahead and make a histogram of now this data. All right, let's see what color we want it to be. Let's do this nice blue. All right, so we have a y-axis and an x-axis. So Y is frequency still, and then X here will be credit scores, right? That's what we're working with, credit scores. And then we have our bins or our categories here, all right? So this will get a little bit cramped. But I'm going to go ahead and put in all of our different categories here, right? So again, this is a little bit, it's all about organization, right? Just keeping all of our data organized. And if you're doing this on paper, of course, which is what I recommend you do, it's a little bit easier to say, keep this a little more organized, all right? So again, I'll show you all of this on our slides when we wrap up here so you can get a better idea. Okay. Okay, so there we have it, and our frequencies range from, I think our highest one is 4 here, so not so much to concern ourselves with here. But let's go ahead and put these in. So for our first category, we had a frequency of 1. For our second, we had a frequency of 1. For our third, and for our fourth. All right, and then into the 500 to 549, that's where we have a frequency of 2. We move up to 3 for our next interval here, up to 4 for the next here. If we move over to the 650 to 699, we're back down to 2. See, we're back up to 3. Again, in our 700 range, 750 to 799, we have 2. And then 2 here as well. So then what we want to do is take a look at the shape of this data again, right? Let's take a look at the shape here, all right? So we have what we would call a negative skew, all right? Negative skew, meaning that we have more scores, or at least scores over here, pulling the data over to the left, so to speak. So remember, try to think of what tail you can grab with your hand, right? Which one is smaller. Okay, so let's go ahead and hop back over to the slides. And here we have it, all right? Here's the frequency table for which we made that histogram. All right, now let's try just one more thing. We're going to try one more thing with frequency tables here. Let's try a different grouping for this very same data here. All right, let's try groupings of 100 instead of groupings of 50, all right? And let's see how that changes the data, all right? So I'm gonna hop over back to the whiteboard and let's get ourselves a new slide and let's give this a try, all right? We can actually collapse the frequencies from before, right? Because now these categories are including, say, 2 of our previous categories. All right, let's not do yellow. That's a little hard to see, huh? All right, so let's get our X values here. All right, so X values are still our scores. Okay, still our scores here. So now we're going from 300 to 399, 400 to 499. All right, so this is definitely a little bit easier and arguably a little bit cleaner, right? We have a lot less to worry about here. All right, and let's go ahead and get our Y, our frequencies over here. So let's go ahead and put the frequencies in here because again, we're just combining the frequencies of the previous groups. So let's go ahead and get these in here. And then let's take a look at how this would look visualized. All right, let's try this out. Let's get a Y-axis and an X-axis. All right, so our X-axis, all right, of course, is still credit scores. Our Y-axis is still frequency. And let's go ahead and give this a try. So for credit scores now, we have fewer categories, right? We have 300, 399, we have 400, to 499, and so on here. All right, and our frequencies go up to, in this case, 6. So we'll put 1, 2, 3, 4, 5, 6 tick marks here. And then we'll just go ahead and plot, all right? So we have 2 in this category, we have 2 in this category, we have 5 in this category. All right, down to our 600 to 699, we have, let's see, 6 in this category here. 700 to 799, we have 5. And then 800 to 899, we have 2. All right, so there we have it. We have a slightly different shape, right? If we compare this past shape with our, we had 11 total categories here, to our 6 total categories here, this is looking maybe a little bit more normal, right? We might describe this as normal. It doesn't look as dramatically skewed as the last. So this is where interval size is important, right? The more intervals that you have, the more clear the data looks. However, it's not always practical, right? If we're working with these large data sets, sometimes it's the best for us to condense it in a way that's a little bit easier to digest. All right, so back to our slides here. Let's take a look again at the percentage calculations here in the event you want to do that to practice on this particular data set. And then there we have it. That's our first look at handling data, organizing and visualizing data. And next we're on to central tendency. So I'll see you on the next lecture.